I'll record to my own computer. Cool. Okay, so if you decided that this is what I'm going to do, I'm sorry, flipped it. It should be like this. So it's not a swell anymore, right? You will have another, looks like you may have another 67 over there. So you can see with a crown type of signature, the lowest point is here, which means you need 2 DIs. And then, so how do you determine where the DI is on the curve here? You need to find the tangent point by the largest distance there, by kind of making a parallel line, move it along the curve and see which point has the largest distance to this line, and that's your lowest point on this curve, and that's where the DI is. So this design, you have 2 DIs. Is that?
Yeah, that makes sense.
Yeah, cool. Yeah, but if you decide I want to change my design, now if you want to, for instance, there's many ways to flip your design here. So for instance, if you say, oh, I want to actually flip the contour pattern off this point, then there's a different, no, actually your lowest point is along this line. Or if you decide that I want to transition into a circled, let me try to clean some of this. Now a circled pattern like that, then there's ways to make the B point the lowest point. Okay. The bottom line is that you need to look at your contour pattern and find out whether B is the lowest point, and if not, where the lowest point is, and that's where you put your DIs. Right? Okay. The next one is the same slope maintained throughout the whole parking lot. You don't necessarily have to. Now, the center line can change slopes, as many of you have done, because you are given the points, right? A, B points. No, they don't necessarily all lead to a 2% slope all the way through. So the key thing is that wherever you change the slope of the center line of the parking lot, for instance, you need to indicate that. Now, for instance, there's some benefit actually, to raise some of the slope, for instance, in this area. Now, if you are having trouble raising the FFE here, now it might be beneficial to raise the slope here, for instance, to 3%. So you have a higher elevation on the curve here. Then correspondingly, you will have a higher elevation for this unit. Then it will be easier to make an ADA accessible, as well as a walkout basement there. So the center line slope, or the entire parking lot, they don't have to be uniform all the way through. But at the same time, you should try to minimize the changing, reduce the constant changes in slopes, so that is not confusing to build. That kind of makes sense?
Yeah, that makes sense.
Yeah, you can change, but don't change it too much.
Okay.
Okay, cool. Next thing. So, well, the HP is actually be in the middle of this parking lot. For this one, yes. The reason being, though, the natural grade is this as the high point, the middle as the high point. So in order to reduce earthwork, we are taking advantage of that natural topography. So we're going up. No, the arrow is pointing down. We're going up and then we're going down, utilizing the original topography. So it's easier to connect back to your original contours. Okay, it's easier to connect the proposed contours to original contours if we follow the natural topography of the site, right? Yeah, it all depends on the context of the site. If I give you, for instance, a depression, no, the lower in the middle, then you would have a totally different design.
Right.
Yeah.
Okay. Thank you.
So go over showing, explain sidewalk requirement. I'm not entirely sure. Okay. So there's another one. More of a general question. Could you show how the contours will be drawn? Yeah. So I think Stuart just went through some of them, right? In order to form a crown, your parking lot contours would look like something like that. And that's definitely not the only way to do it, okay? No, you can choose to even flip it to a W. No, the only thing that cannot change is the crown, because the crown requirement we gave you. So you have to have a crown like that. But no, I just want to show you there's multiple options. But the most straightforward one would be the simple crown signature. Okay, you can carry that all the way through to this intersection. And in order to direct water away from the buildings, this is high and that's low. So it should be like something like this, right? Something like that, right? And again, there are multiple ways to deal with the middle. Now for this one, yeah, definitely I want water to flow there. I'm sorry, I'm going out of page, but the same thing for that side, I want water to go. Sometimes it forms a swell. Sometimes you can use a uniform slope or sheet flow to direct water away. You don't always have to create two swells on the sides. Okay, when you can do sheet flow, create sheet flow. So in the middle, there's basically you can have two swells that will converge eventually into the middle, but also you could put a wall here. You could put a wall in the middle. So this is high, water going this direction all the way through. So basically the contours here would continue this pattern, which is very similar to what Stuart just drawn, okay? And then on the other side of the wall, the water will basically just flow in that direction. So that's one option, okay? The other option without the wall would be the two swell kind of pattern there. No wall, two swells. Now then you need to think about, how do I create a swell, right? So it will be something like this, like bunny ears.
Right, okay.
Yeah. And your high point of swell will be something in the middle between that and this. Okay. Yeah, that's the basic two ways of creating this one. And there are a third option, which would actually have I'm going to clear most of this. I'm not recommending that one because that's the most complicated one. It's not necessarily the best solution either, just because you have a narrow front yard. Okay, another way of doing this would be, I'm creating swell all the way through, which means my swell would go this way and that way, which means all my sidewalk, not all my walkway leading to my building would be elevated bridges. Does that make sense?
Yeah.
Because I have a swell going all the way through, across the entire length of the building. So all these purple, pinky bridges, they are a little bit too hard to design for the narrow, because the distance here is pretty narrow. So I'm not recommending this option, but just so you know, there is this option. This distance is too small. So meaning that the swell that you create here would be steep in terms of their side slopes.
Okay.
That makes sense? Yeah, but I want to put that option out there, and it's done before. You know, sometimes you can even see it in town where you have little bridges in front of the apartments.
Gotcha.
Okay, so the simplest one would be the first one with a wall, and then the second one is not that difficult to create with a bunny ear swell in between.
Right.
And then the third one will be creating elevated walks leading to your units. And I personally do not recommend that one given our short timeline here.
Okay.
Okay. So moving forward. Oh, TC and BC locations. Again, wherever you have tangent points, you would need a TC and BC. And wherever you have a dead corner, you would have a DI. Okay. I want to point out to everybody here. Once you have all your parking lot contours out, the next thing you will need to decide is actually where your contours climb up from the curb, right? So how do I find where the contours connect on the curb with all these different shapes of the curb? No, the shape of curb, ignore that. The key thing is to find midway. Okay, now let me show you what I meant by that. So let me scroll down a little bit. On the south side, it's a little easier because we need to do is to find out where the midpoint is, and there's no the shape of the curve on the south side. It's not that complicated, so it's a little easier to find where the midpoint is, right? But when you have that, the key thing is to find where point 2 is, of course, along the center line, and do a parallel line. Okay, so that's where, and then you actually have 2 of the 0.5. This is your scenario. Okay, this means that your, for instance, this is 71, I think. Yeah, if this is correspond, if the slope are similar, well, double check. No, if I just take your 70 contours as the correct number, that's where a 70 climbs up, not climbs up, actually connects on the curve, right? So I'm looking for where 69.5 is as the BC. So those 2 points are where my 70 here would connect to. And you need to make sure that actually this one hits both points. Yeah, so do not be confused by the shape of the curve there. Always find where the midpoint is and do a parallel line, and that's where, for instance, for this one is where 71 would be. Okay?
Okay, thanks.
Okay. Anything else? Yeah, BC. Okay, so I think that's all your questions.
Yeah.
We're pretty good on time. Why don't we move forward, and if you develop more questions, if we have time at the end, we can answer them. Okay.
Yeah. Thank you.
Alrighty. Cool. I need to find my names list. Can you remind me who's next? I think it's Eric. Okay. Alrighty. Let me scroll down. Eric, are you here?
Yep, I'm here.
Yeah. Okay. So we got 3 questions here. My swell lines are wrong. Yeah. Yeah, I think we kind of answered that just now with Maeve. The slope from my given elevation to the given. Yeah, This is totally fine. No, you're 1.8% slope along the center line, but you have a 3-inch crown. So that kind of already ensured that you will have enough drainage on the driveway. So that's totally fine. Again, the center here is not a DI. Where the water drain, you will need to find wherever the lowest point is. Okay, so I suspect that there is another one based on this. So that there's another contour here. So your lowest point you will need to look for where the furthest. No, again, that's the tangent point. Okay, so that's where your DI would be. 2 of them. And another thing is no, your contour stopped there. It doesn't keep going.
Yeah.
And it stops here. On this side, you have a very tiny little one. That's a closed contour.
Mhm.
Okay.
Yeah, I did that just to like
Yeah,
act as a
I totally
placeholder.
understand. Yeah. And when it comes up, you need to flip them. Yes. Yeah.
Yep.
Okay.
Yeah, I got that more in the introduction today. I started figuring that stuff out a little bit better. So I have a
Cool.
better understanding of how, like, I can fix my swales and things like that.
Yeah, awesome. And anything else, given that we have time here?
I just wanted to check that, like, the porch elevations, should they be the same as the top floor FFE?
Yes. Yeah, that's
Okay, I just wanted to check.
correct. So why don't we use the time to check one of the unit to see if it works? Which one do you think is, you had more challenges?
I'm not sure.
Not sure. Yeah, I think we'll need the tick marks to know. No, you figured out this side. So let's check this one. Okay.
Mm.
The 4th unit. So we have 71, 70, 69. So here we're close to TC. No, let me change to a thinner line. Close to TC equals to 70. Okay, so definitely you need steps here. And your bottom is 64. Let me, so this is 5, 6. And I need to actually look at look at where the trees are. 6, 7. So if this is 64, yeah, 64 doesn't kill the tree. So that's fine for there. Okay. So looks like this it potentially, the corner is not time to determine the corners yet.
Okay.
It's because all these walls are retaining walls. Okay. The corners do not have to be 0.5 lower than the bottom FFE. It can actually be higher.
Okay.
Because,
Right.
for instance, if I have I will definitely need a wall here, which means I will have 2 BW here. No, the bottom of wall will be different from the bottom wall on the other side of the retaining wall. And this one will be determined by your bottom FFE, right? That wall elevation would actually be the same as the bottom FFE 64. But on the other side, it could be a lot higher, and that's what the wall is for, right?
Mhm.
So if you have a 64, your next contour will be 63, and the distance here, I suspect, will be exceeding 50 feet. That's your original 63, okay? If the distance here exceeds 50 feet, that means this area is less than 2% slope, which means that doesn't drain, which means it could be a problem.
Okay.
No, I can do a quick measurement on my other computer here to see what's the distance here. Give me 1 second. My suspicion is that it's over 50. Yeah, 56.57. So it's kind of, yeah, it's borderline. So it's safe to say that 64 is a little too low.
Okay.
Yeah. So we need to aim for higher, which will actually make it easier. I know, no, it's kind of, no, when you make this higher, that's higher, you need more steps. So you need to find kind of a balance between less steps in front and less contour movement on the back.
Mhm.
Right. So
Right.
let's aim for higher than 64, but not too much higher, because you don't want to create like 5 steps in front. So if we maximize the walkway here 5% and use 3 steps. Now let's try if that can get us to, for instance, 73.5. Okay. If not, what we could do is we could start our walkway earlier, or we could raise the slope a little bit here, so that this is higher. Is this given? I don't think this is given. No, this is not given. This is given. Okay. If you raise this a little bit, then that will be higher. And this can be higher with fewer steps in front, and the bottom can be a little bit higher. So there's multiple ways, you can adjust every one of those flexible parameters by a tiny bit. Maybe, you won't, for instance, need a lot more steps, for like 4 or 5. It's kind of not, it's not desirable to have more than 4 steps in front of a residential building.
Right.
That sound good? Yeah.
Yep, that sounds good.
But you get the idea of how to check for each unit, the back and the front and the back, and just kind of adjusting them in a system, so to find the balance.
Mhm.
All right.
Okay.
So next step, I think for you, the next step would be, I could almost say these 2 sides can be done in 2 stages. Okay, you can choose. You can choose to work on this unit a little bit further, to make sure that you have the top FFE and BFFE all appropriate, and then decide whether you need to adjust that just slightly, not dramatically, and then find out all the tick marks here. Okay. After that, you need to check the BFFE and the TFFE for these 2 units. That one is actually the easiest one, and this one is similarly challenging to the last one. I would say this is the most difficult one. Okay. And then after that, you will try to determine where the contours connect on the curb, and then start working on the pattern in front of your building. Okay.
Okay.
Very quickly, I think these 2 pretty low. 62. You're kind of getting to the area where you're starting to kill the tree. Sorry to say that. Oh, you have less trees, I think. Seems that you have fewer trees, which is good. 5. Okay. Let me very quickly. 5, 4, 3, 2. Still, I think you should raise this one, because your 1 is here, so your 2 has to be 50 feet away. I would say, in order to not dig too much in the back, raise this is actually pretty easy with this unit with a few steps in front. Okay. And for that one, for this one, the same thing. I think this can be raised. Yeah, both of them can be raised. 63, 5, 4, 3. That one, the same thing. 3 is here. So we're aiming actually at 4 here, because I can kind of estimate this is about 50 feet. No, try not to move the 3. Raise 4.5 there. Okay. Alrighty, that's my recommendation for a next step. We're good to move forward.
Yep.
Awesome.
Thanks.
Cool. So next, I think we have Alec, right?
Hello.
Yeah. Hey, Alec. Awesome. Let's take a look. So I can see some similar issues here with the bottom FFE being fairly low for all of them, I would say. So yeah, this 5, 4, 3. This one, yeah, this one may be okay. This one may be okay, but all the other bottom FFEs, I would say, yeah, too low. Because this is 63. Yeah, that's 3. And no, the 63.27 would put would keep 63 in its original location, and that one is too low. This one, 3 is here, so you can see the 3 and 3. No, the distance between them are pretty big. That one is even more because you have 6 here, 66. No, as the original contour here. So that one is too low. Okay. So work on 1, 3, 4, unit 1, 3, 4, bottom FFE and top FFE first as your next step. Sorry, I kind of jumped into looking at that without looking at your questions. Let's go back. Oh, actually you have, do the buildings have to have the same FFE on the right as they do on the left? The only, no, you need to keep the 2 units belonging to the one building the same. That's one set. That's one set. And the difference between this one and that one would have to be in 8 inches increments. Okay, so you don't have to keep everything the same or every unit different, but just keep the set of 2 units at the same FFEs. Do we need to have a swell in between the buildings? I think we went through that. Can we utilize the water if it's coming down that and make that area into a pontless waterfall? It doesn't really, I can see it become a little a water feature. It depends on sort of the slope that you're creating. You know, if you create an abrupt elevation change, it could be a waterfall. If you design very gently, it's basically a swell. Okay, you could design an abrupt change in elevation in combination of a wall in between. You will have plenty of opportunities to do artful designs for stormwater next semester. I would not recommend doing it right now. I know if we have a month left, go for it. We have about a week, and I think I'm glad everybody had a break, you know, for Thanksgiving. But overall, this semester we see burnouts, you know, from both the students and the faculty. I don't think this is the right timing to go for it. Hope that don't discourage you, but definitely yes. Creating a water feature has a lot to do with the topography that you're creating, the elevation change, you know, for along the water course. I would actually personally see to it next semester you do this, okay? But let's get through this semester first. Should I lower the buildings, make the parking lot the highest? Not really, because you have the curb, right? You have the curb. You have the curb, so the parking lot drainage is taken care of by the curbs. The curbs is serving as collectors. The curb help you collect the water to the DI. And the relationship between the top of the curb and your building, it has to be positive drainage, meaning this is definitely higher than that. Okay, so no, I don't think there is a absolute comparison between the general elevation of the parking lot and the building. You should compare, you should really compare this to that. Making sure water is draining away from the building. And always, the general rule of thumb is buildings are higher. Buildings are definitely higher than its surroundings in order to not to be flooded. Okay. ADA housing would be near the road. ADA housing would actually be the higher units. Will be closer to the middle of the parking lot because it's easier to raise the not raise, is easier to create the 9 feet difference between the front and the back with the ones that have higher elevations, with the ones that have the higher elevation in the front. And these two units have the higher elevation because it's closer to the higher area of the parking lot. So I'm not sure if that answers your question. And if you need more clarification, please, just feel free to unmute. Making sure that you, did I lose you, Alec?
Yeah, no, that was helpful.
Okay. So anything else that you want to ask? I can see that you were taking the third approach, now designing a swell all the way through in front of the building. No, we're not recommending it at this point.
Yeah, I was gonna ask
yeah.
you, like, would it make sense if we had all the water from in front of the building straight into the parking lot, or that would
Yes. Yeah.
so just
Yeah,
have
that's
it?
what we. Yeah.
Okay.
Yeah, that's the number one option. First option, where you drain everything onto the parking lot.
Okay. All right.
Yeah.
That's not too bad. All right. Thank you. I appreciate it.
Cool. All right. Work on the parking lot contours first, okay? And then work on the FFEs, unit 1, 3, 4, and work on connecting the contours out of the curb to your original contours. Okay?
Thank you.
Cool.
I have a quick question,
Yeah,
Wuhan.
go ahead.
So when you say that you want us to drain the stuff onto the parking lot, I'm just struggling conceptually with how would we, like, what's the way to do that? Like, when you say that,
the contour pattern that you're aiming for is like this. Okay, so in this way, you would have all the water draining that way to your parking lot. And on the side, on the right side, you may have to create a swell. Very likely you will have to create a swell. And on this side, it's possible that you can use sheet flow to drain the water away. And then you need a wall here. So the entire area here is high, but then you have a drop. The reason why you need that is, because the conflicting drainage in this area, this is all going that way, but I want this to go this way. Okay, so that's why you need a wall there. And if I'm drawing in cross section, I have the buildings. No, this. Oh,
Yeah.
sorry.
Wait, so
Yeah.
you're saying we need a literal wall? Like we need to draw one in AutoCAD?
Yes,
Like,
you need a
okay.
wall. You need a wall. Oh, you need a wall there. And on this, on the north side of the wall, you're draining in this direction, right? But then on the other side of the wall, on this side of the wall, you want it to drain that direction, right? So you need a wall. You need a wall to create different water flow for different parts of the for the front and the back of the building. Okay, so no, all these are filled. I'm sorry, that looks horrible. Yeah, and then remember that the height of the wall cannot exceed 4 feet. So for instance, if you have a 71 and a 72 here, if this is 72, that may be 72.5, which means that may be 72.5. And you can drop at on the other side of the wall to 68.5. Okay, and then no 68.5, then you can have a pretty gently sloped area in this. That's not too steep because your start point is 68.5. Okay, it's not 70 or 72 anymore. So you're not creating a very steep slope on the other side. You're not doing this. Does that make sense? Kind of.
That part makes sense. And then the other thing, I'm just because you were drawing it the certain way you are. Is there a reason why the actual proposed grade change, the way you're drawing it, is like that? Shouldn't it be inverted, where I guess the not the ridge, but the valley is like flowing down into the site instead? Sorry, towards the parking lot instead of like that kind of arrow shape you have going on. Like, shouldn't it be the opposite of that? If that makes any sense.
All my arrows in this area.
Not the arrows, the lines you've drawn, the black lines. Shouldn't
Oh,
it be
the black lines.
flipped?
Yeah.
Like
So, well, this is high, right? That's high. This is high. This area is high. And I'm actually drawing like a summit signature. My water flows from high to low. So this is the correct.
so we should be treating the
direction.
buildings as the summit of.
Yes.
Okay,
Yes.
that makes a lot
That's
more
correct.
sense.
Yes. Yeah. Okay. Great question.
Sorry about interjecting.
Oh, no worries. We do have time today. Alrighty, we're good to move forward. Okay, sound good.
Actually, sorry.
Yeah.
For that wall, will we need to show all of those uniform contours? Or since it returns, I mean, not returns, but since it kind of follows the grade, I had like a wall in place, but it wasn't totally correct and I wasn't sure what to do with the contour lines following like after it.
So what we do is we calculate, so let me go back and erase everything. Hypothetically, if we have contours connecting like there, like this, I would want to try to create those two cannot be further than 50 feet away because I need this area to stay above 2%. So
Right.
that's how I get to this contour. So if this is 71, That's how I find my 72 contour. Okay, then my wall needs to be in between, connecting the two corners of the building. And then I calculate the highest point, which is here in the middle, because it's the furthest away from these two contours, right? Making sure that at least a 2% slope is created between this highest point and my two contours, my 72 contours. So suppose that gives us a 72.5 at the bottom of the wall. For the other side, no, for if this is the elevation that we created, then we have a 4-foot drop. No, so the bottom of the wall here would be 68.5, right? And then you start measuring, not measuring. So you need to decide, once you have all these contours, you know which ones needs to be moved, which ones do not need to be moved. Then you can get a sense of what's the slope that you created here is from the 68.5 to the contours that remained in place. Okay, so it's not immediately you know what the contours in the middle look like. You'll need to base that upon what's the last, what I would say, what's the first original contour that you don't have to move. And then you try to create a semi-uniform, uniform for the first contours, your uniform slope between the two buildings. That kind of makes sense. For instance, if the 64 is the one that you don't have to move here, then you have a 4.5 feet difference between this line and your 64 contour. So you're trying to evenly fit in 4.5 contour spacing. 8, 7, 6, 5, 4. So it will kind of look like that.
That makes sense.
Yeah.
Thank you. I think so. The only thing is the distance between that 72 contour and the start of the wall. Does that determine the height of the wall and what that should be?
The
Like,
height of the wall is determined by you.
Okay. I mean,
Yeah.
like the 72.5. Like, is that
Oh,
based on a
okay.
calculation of the distance between that and the contour?
Yes.
or-
So that is dependent on this calculation here. Wanted to change that calculation. You need to make sure that's at least a 2% slope from the 72 contour. You're basically trying to find out the highest point along this line, which is the furthest from the 72 contour. No, so for instance, this point will be lower, right?
Mhm.
Or it could be, no, they could be the same, but they are, no, all the spots along the wall here will be higher than 72.
Right.
Right?
Okay.
But
Yeah.
at least they need to maintain a 2% slope from this point, which is the furthest from the 72 contour. Yeah, I know this is getting a little small.
Got it. That makes sense. Thank you.
Yeah, cool. Righty. Next. Turn on this one. See the list. Devin.
Good morning, Wuhong.
Devin here? Cool. Righty. Bunch of questions. Let's see. Okay. Spot at here is kind of high.
Yeah, that was a
Yeah,
point.
we'll take a look. Yeah, I just want to read through those. I've set the slope in this at 2%. Does this work? 2.9. That's okay, I think. Calculate spots. That one's lower than HPS in the lot. Should be able to close. So that's 68. We'll take a look there. Best place for ADA. No, all these three are actually not that difficult to put ADA. Do these sidewalks work? Oh, what's that one? Same thing, I guess. So trials of three vertical change, range that. Okay, we'll take a look at the units. What is this middle one? Okay, yeah, let's zoom in. So you have a high HPS, 4% slope, which is a little steep for a parking lot, but I don't think it's not acceptable. Okay, and this slope in these directions. So I don't think you need to set a slope there. No, because your parking lot contours are mainly determined by your centerline slope, which you have here as 2.9 and that 3-inch crown.
Oh, hold on. So all of my any slope what my parking lot, anything that's running parallel to my central line slope is gonna take on the slope that I put on for 2.9% slope.
Yeah, so what I think you're asking is that is 2.9.
Yes.
Well, this is 2%. I believe that's true because of the 3-inch crown. So yeah, okay. You don't need to set it. The 2% was predetermined by the 3-inch crown.
I don't understand why, but I'm glad I got it right.
Cool. Yeah. So I'm gonna very quickly just explain. If I'm drawing a cross section here, okay, the 4-inch crown means the driving aisle. Basically, I forget. Yeah, this is 12. I remember. Is it 12?
It's 12.
Yeah. If this is 12, a 3-inch crown just means that is 1 over 4, 0.25 inches, feet. I'm sorry, right? That distance, that crown height there, which means the slope here is 1 over 4 and then divided by 12. So it's 1 over 48. It's very close to 1 over 50. So if you use a 2% to calculate that, it's close enough to 1 over 48. So you can directly use a slope equal to 2.0% to calculate your corner other elevations on the parking lot. That's fine. Okay.
So then everything else that would respond to, well, everything else as far as my parallel slope percentages would respond to, everything to the right of my HPS would respond to 3.9%.
Yes, that's correct. Okay. So those are, let's check your check your FFEs. Okay. So this one is a 64.81. Yeah, that should, well, it's a little still. That means you have to drag your 64 up, which is fine because you're not moving your 68. So this should work. You don't have to, these two should not be varied. Those two will stay the same because that belong to one set. This one, 65.15. I think this is a little too high, unnecessarily high. So what I would recommend for doing this one, I know this would cause minimal, actually this will require fill in the back because you have a 65.82 and your 65 is over here and your next contour is 64. So this will require you to fill the yard and fill here as well. So that's a double kind of cost. Okay. So for this one, I would actually recommend calculating from this one, and then do a 5% slope right there. You probably don't even need 5, but we can start with 5% slope here based on that. Okay, and then you get your TFFE, and then you minus 9 foot to get your BFFE. That would not be too far away from 64. I think that's the only thing that's needed for this unit. So if you have time, after our review, do the calculation. If it's not correct, we can talk again, but I'm pretty confident that it should work. So for this side, 66, I think this is the same thing. You need to feel here. So definitely you can lower the TFFE. If you added steps to make this work, remove those steps. Then that may be the only thing that you need. Okay.
Mhm.
And that one seems to, yeah, that one should work pretty well. Still, I think, well, let me move over to that side. Your 63 is over here. So this can be lowered as well. No, if this 63 is what you want to maintain, you can measure that. That's probably close to 50. So you can use, for instance, you can use that one. Get rid of that one. You do not want them to vary between the two units, because that actually requires you to create two separate pathways because they're not at the same elevation. So putting them at the same TFFE will eliminate one of those. You can basically use actually the center, that line. Now use those as your walkway.
Mhm.
They can share, and then get into the two units. So if you have steps for that one and for that one, remove them. This one it's pretty close to what it needs to be, the last one.
So everything should be responding to the 64 contour? Is that what it is? The one that is this one?
Well, for this one, yeah, 64, 64, 64, yes. For the last one, it's hard to respond to 64.
For
The
the last
way you
unit?
had it, yeah,
All
the
right.
way you had it, no, yes, the last one, because your original contour is 66. So the way you had it requires 64 to be pulled up, which is fine. No, you're not killing the tree, so it can work.
Mhm.
Yeah, so this requires your 65 and 64 to be moved up using that wall, which is not a problem there. Alrighty, so that's some of the, now let's take a look at the this connection there. So we're trying to work on the transition. I am not quite sure what your, so for that spot, it would only be determined by the intersection there. I mean, by the major road. Now, whatever the slope is for the road, you should just continue that. No, interpolate. No, I should clarify. You should just interpolate between, come on, between that and that, and find out what this is. I mentioned to Maeve that Thursday I'll make sure that Stuart goes over the intersection transition, so we know exactly how to calculate this area. This definitely can be the last thing that we will worry about. Does that make sense?
Okay, so you're saying that this percentage, this slope between this area and this area right here
Can be carried through. Yes.
is what's going to determine this and this
Yes. Yes.
from
Yes.
the relative point of this and this.
Right.
Okay.
Yeah. Basically, you calculate the slope of the road based on these contours, right? Based on the existing contours, and that slope will be exactly the same from this point to that.
Right. And then it'll be the same deal from here to here relative to this and this.
So the slope here will be the same. Yeah. The slope there will be the same.
Gotcha.
Yeah.
I use 2.9%. Is that, I think that's what really, I thought I was being clever, to be honest with you, Wuhong. I was like, oh, I'm going to send it up high because then I can do whatever I want in the front.
Yes. Yeah. No, that's a good move. That's a good move. Because we haven't tried enough alternatives. There's a balance between creating a high slope in the parking lot, and so I would say for some of the areas, for instance, for the two closest unit, you probably don't need that high to make it work for ADA and backyard. But
No.
I'm not dismissing. Yeah, I'm definitely not dismissing your 2.9% slope there. The 3.9, I think that was a little too high, but I understand why you created them. I think no, we should move forward. We should move forward, crafting a solution that has no errors, and then reflect upon it to see what can be improved. Does that
Okay.
make sense? Yeah, yeah. I think is definitely an iterative process. Now you just need to pick a start point. At this point, make no mistakes. Make sure everything conforms to the desirable range, and be able to critique what can be better. No, I don't think. I think at a certain stage you need to move forward so that you can complete the project.
Mhm.
Okay. I remember there was another question about a swale here. Okay. The swale. So one of the first next steps for you would be drafting up the parking lot contours. Okay, so you need to draw the contours. I don't know where they are. 71, 2, 3, for instance. And then I don't know. No, for instance, if that's that's your contours. So that's 2, 1, 0, and that's 9. Okay. So then okay, that's where 69, okay, 69 actually is over there. So I'm not sure it's time to determine that yet.
Okay.
Because we want you to work in this direction. Okay, so that one means your 71 would do this. So that actually means this one would be probably 72 point something. Oh no, 70 point something, not 72. That kind of makes sense. So even no, you probably don't even need an HPS here. You don't. Your contours would likely just look like that. Kind of makes sense. So don't identify a spot elevation yet, because you're still not working on a concept. That you move forward, have your parking lot contours, and then start the concept level for these other contours. Exactly like what I just did.
Mm-hmm.
Yeah. So for instance, you would do something like this, right? So kind of eyeballing what your next contour would be.
Can I ask a
First.
question quick? Sorry.
Yeah, go ahead.
About the swale over to the left.
Mhm.
So I kind of had a similar look, but my 70, I couldn't get my 70 into the swale and then also joining with the building. Is that what you said there with removing the high point and just having them all run like to the building?
Yes. Yeah.
Is that a better solution?
Yes. Yeah.
Okay. So would that still even be a swale over there, or is it just changing
No.
them a little bit?
Just changing them a little bit.
Well, do we
There's
even
no
need a
swell. There's no swell in this area.
Yeah, is it a requirement that we have a swell to the left of all of our buildings?
No, you don't have to have a swell.
Because doing that for me would be much easier, even if I brought down my high point, because both of my LPSs are still rather high.
Right. You don't really need a swell on the left side, but I think you will need one for the right side.
Mhm.
Just because the right side you have to actually modify the lower contours and have it attached to the wall. But try it out on the right side. The left side, I don't think most of you, I don't think you need a swell for that one.
Okay. I guess that's all my major questions, really.
Cool.
But I guess I know that I need to take down my center point or my my high point of swale in
Mhm.
the parking lot where it breaks in half. But
Yeah.
I guess I can use a 2% slope instead of following up with a 2.9% slope. That might be a better solution.
Honestly, I don't think you need to change your centerline slope at this point. I don't think you need to. I think you should use these as starting point and move forward in
So
in drafting up the other contours.
Mhm,
What I'm trying to say is right now your two centerline slope will work.
mhm,
Yeah, they will work. Though maybe they create a little bit more feel than desired, but that's fine at this stage. I really want you to start working on these things. Start hitting on what actually, for instance, um, Stuart said about these details that you will only have time to worry about them if you start working on the draft of the contours right now.
mhm,
Yeah, you have a lot to work on forward. I don't want you to stay in this stage.
mhm.
The first stage, I think it's time to just flip that page.
Okay.
Yeah.
All right.
Okay. Sounds
Then
good.
it's
I do think we need to move forward because we still have 6 students.
Wait, Professor Wong?
Yeah.
Sorry. Before you move, are you saying that we don't need the one that I circled, the swale right there? The pink circle.
You don't need a swell there.
Okay.
Yeah.
But we could.
You could,
Optional.
but
Okay.
likely you won't need to create a swell on the left side.
Gotcha. Thank you.
Okay. Alrighty. Yeah, let's try to move forward. Yeah. Okay. Yeah, Devin, if you have more questions, feel free to reach out later. Okay.
thank you, Wong.
Sound good. So I think the next one we have Connor. Connor, are you here?
Yeah.
Okay. So let me zoom in. So the first thing that I recognized was the crown. The crown signature is not there yet. Okay, your parking lot needs to be having a crown pattern for your contours, not like that, because all this is doing is for water to sheet flow. Okay, so the tick marks have been identified, but use the 3-inch crown to determine how how your contours should go. Okay, and because of that, we went through with other students, you would have 2 DIs at the end if you keep this crown pattern going all the way to the end of the turnaround. So that's your contour pattern there. The second thing I noticed is that contours do not connect directly like that because you have a curve. Okay, So what you need is to find the midpoint. No, Stuart also demoed that one. No, your 71 contours would go along the curve and then come out. Okay, so that's the second thing that I noticed. The third, can we use 4 retaining walls? Well, depending on, I would not say a definitive number yet, because it really depend on how you design these areas. Looks
Well,
like
I
this
wanted
is
to I was gonna do so on the right side where you had the one retaining wall on the far right side. So I was gonna
yeah.
do like one right there and then have a gap with the landscape bed in between and put another one because that's how I originally had it and it worked out perfectly with the water drainage and the contours on the bottom.
So
So I had like 2 retaining walls like back to back basically on both sides on the far right townhome and the far left townhome.
yeah, definitely you will need a retaining wall here. As I mentioned to Devin, you should keep those FFEs of the 2 units the same for the same set. Okay, so this is considered one building. They are connected together. So for building, for construction reasons and for aesthetic reasons, they should match in terms of their facade. Okay, so those FFEs do not vary between the 2 units.
But like realistically, when you look at townhomes, they're never like 2 townhomes next to each other are never level with each other.
No, I meant that and
So,
that
like,
will be the same. But this, oh, this can be different from the pink one will be different from the red one. Okay, so and also, as I mentioned to other students, try to aim for BFFE at 64.5 for this unit. That one, 65 would work. And this one, 65 would work pretty well. And that 62 is a little too low. 62 and 61 is a little too low.
when
No,
I had
because
because I'm gonna put the daylight basements on both on where the 74 is, on both of those ones
yeah,
on
this
side.
works. The ADA should
Um,
work here. Yeah.
And then I had when I did my contours at the bottom, when I graded the back of it, it worked out perfectly with the bottom FFAs. I just didn't place in the contours yet on CAD.
So can you annotate to show which unit exactly?
Yeah, hold on one second.
Yeah, let me just put it in the center.
How do I annotate?
Yeah, yeah, you should be able to click the annotate button.
Okay, here it is. Let me get my.
Yeah, let me scroll down a little bit more so that you can see the other contours.
And what do you want me to show you?
So you were mentioning which units you want to do ADA, which ones you want to have walkouts, and you were mentioning.
Well, so the ADA ones are these 2 M ones, and it worked out perfectly because of my contours originally. And then these.
So can you
daylight.
explain a little bit more what you meant by worked out perfectly?
All right, hold on one second. I have it drawn on paper somewhere. I can't find where I have the paper, but
Yeah.
Yeah.
So what I think you were trying to explain is that if I have 70.5 here and I go up to this unit at a 2% slope or other percent that I can get to TFFE equal to 70.67 pretty easily. But if you look at BFFE, you are at 67.67 and 61 is here, meaning that you are at 61.67. So in order to maintain drainage in this area, you need a 2% slope, meaning that you need to drag the 61 up somehow. No, not that much, but you need to measure like 64 foot, 34 foot, and then drag it up, which means that you're basically this tree is gone. So that's why we cannot move the 61. So we can move 62, right? We can move 62. So what the minimal, I mean, if you wanted this area to be low, that's totally doable. No, you could use the 61 staying here and measure 50 feet, and that's where your 62 would be. Okay, and then calculate the distance here, and I know, okay, that might be getting to 62.33. So instead, this would work better. The next one, 62.33 would work better. And then their TFFE 71.33, and based on where your 70 is, and this would work, I would say, pretty well. Not the left one, but the right one would work pretty well. As long as this slope still exceed 2%. Okay. I think you will. My sense is it will exceed 2, less than 5. So be sure to examine all of these units to make sure that you're not removing an existing tree. This one definitely needs to be raised. This one definitely needs to be raised. What? Raise this. The 65 here, I think, would work fine. And the 65 here doesn't need to be so high, but it could work. So it's time. I think it's time first to fix your parking lot contours so that you know more confidently what these elevations are, what these elevations that leads to the walkway and the units are. And then even if you are, I think it's time to put on exactly how many steps and the percentage slope of the walkway leading up to each unit, because it's checking whether or not your TFFE and BFFEs would work. Okay, after you have checked all the TFFEs, BFFEs, then start working on the other contours.
So how I had it was what I wanted to do was retaining wall like that, and then 5 feet behind it, another retaining wall with a landscape bed in between for drainage reasons. And I had the contours. I had the 63 come up, the 64 come up, 65 come up, and then same with this side. I did the same exact thing, and I had the 62 come up, 63 come up, and 64 and 65 go through the wall. And it worked out perfectly for drainage reasons. Same with the parking lot. I'm so confused with the parking lot because I have it graded so it drains to that drain inlet from there and to these two ones from there. So I'm like very confused. Why.
Again, you have a crown. You have a crown. So you can see there is no, because your water is draining both ways. So you have 2 DIs on each side of the crown. What you need to look for is the furthest point from the closest contour. So if I erase this one, suppose there's no contour there, Let me just draw. So if these are the contours, I'm looking for the furthest point from this contour, because the further we go, the lower we get. So we're looking for the lowest point, right? So what you need to do is you need to find the tangent point, okay? Find the tangent point with the furthest distance from this contour. No, I should draw it perpendicular. And that's your DI, because that's the lowest point along the curve. Okay, your original contour pattern, it's creating sheet flow all the way through. It's creating a long path, a long drainage path in the parking lot, instead of directing water toward the curb. Move water quickly off the surface. Instead, the water is running in a long path
I'm
to the
just
end.
confused because you just said it's the water's draining still. So like
What?
I'm still very confused because you just said the water's still draining to the drain inlets where I have with the contours I have.
Yes, with contours, your water is always draining from the high to the low,
Yeah.
right?
So
But in the parking lot, we're creating a crown here, and your contours are not creating a crown.
they okay.
Okay. So, and then we have about 3 minutes left, but I want to say you don't need two walls here because they are essentially performing the same function. What you would have in terms of the contour pattern there would be you have a wall, and then you have your contours attached to the wall, creating a swale. Why it's not showing up like that? So that likely is what your contours will look like attaching to the wall. You only need one wall at either end of the units.
Well, can I do two walls at both ends of the units? Or like one on this
For
side, one on the other side?
the area between the walls, they're not doing much,
Okay.
right?
Yeah, I guess.
Yeah, the areas between the walls, they're really not doing a lot. So one wall can perform the function of connecting those original contours perfectly.
I mean, like when I was thinking of this, I was thinking in like real life terms of how an actual like how every like real life stuff would apply to this. So that's kind of how I've been designing this whole thing this whole time.
So walls are expensive to build.
Yes.
Yes, yeah,
Very, very
you
expensive.
can, yeah, they are expensive to build. And if only one of them can perform, we don't really necessarily need to. And if you have examples that you can share with us, and we can talk about those examples with you. If you have pictures showing two walls, as if they can be good examples, then we can definitely talk with you about those. But I don't really recall such examples as good ones in
I don't
real
have
life.
them on hand right now, but I do have them from like job sites that I've done in landscaping. And
That's well, we can definitely continue this conversation offline. No, we're learning grading all for a long time. For next semester in stormwater, we have plenty of opportunity to discuss this if you would like to.
yes, I would because I'm still very lost because yeah. No, I definitely would like to talk about this more.
Yeah, sounds good. I see that we have office hours with you on in the next few days. I'll be happy to talk about these.
All right,
Yeah.
thank you.
Okay. Alrighty. Who's the next one? Is that Roy E? Still trying to
Yes,
bring up my list. Cool. Awesome. Clear everything here. These two spots elevations located in correct place. Oh yeah. So the spots here, what you label should be at the tangent points. Okay. You can have those as when you to help you calculate, but you don't need to label that in the end. All you need to label is the ones that I just pointed out in red.
I see.
Okay. Next one. So around the house labeled correctly. So in terms of, let's take a look at your FFEs here first. So definitely this is too low. Okay, too low. If this is the top FFE, then definitely too low because you're at 61.05 at the bottom. No, you're definitely removing the trees there. And 71.75 still too low because your bottom is at 62.75. And your closest contour now here is actually 64. So meaning that you have to move a lot of the contours in the back. And then this one, 62.2. You're not killing the trees, but again, I think we're unnecessarily removing many of the contours in the backyard. Same thing. So all your, I would say all your FFEs for the 4 units are too low. Yeah, we went through quite a bit with the other students in the earlier hour. So hopefully you stayed the whole time, or if you did not, go back to the video. Okay, I recorded today's breakout room and I'll upload on Canvas. So if you still have confusion on this part, make sure you go back to the video.
Oh, so there will be a link on Canvas for this breakout room?
Yes, I will.
Oh,
upload.
wonderful.
Yeah,
Okay,
I
thank
will
you so
upload.
much. Yeah,
Okay.
that's really helpful.
So how do you label these, the house corners? You follow the same principle, okay? You follow the same principle of BW at the corner, BW, TW at the end of the wall, if you have a wall, and then those ones. You don't need one in the middle unless you're creating a different pattern here. If you're saying my back patio is flat, then you just need to include a line, and that indicate that you're creating a back patio that's flat. And with these spots, you have explained clearly what the design for the back patio is, so you don't necessarily need another spot there. Okay, only if you're not doing the regular kind of uniform patio, if you're creating, for instance, a different pattern in the back, like for instance like this, then you may need to indicate a different spot to create positive drainage or not, or other. No, only if necessary you include more spots as that's not at the corners or at the end of the walls or anything. Okay, so okay, let me try to zoom back out. I wanted to quick look at, so you have to take points. We need to move yeah, we do need to spend a lot of time this week on this one because your FFE still needs to be revised. Again, I know the workflow that I recommended to almost everyone is work on your parking lot contours, verify your TFFEs and BFFEs, and work on where contours connect on the curb, and work on the contours around your building. Okay, after that, you work on contours in this area. That's your workflow.
I see. Thank you.
Yeah, sounds good. Righty. We'll try to move forward with this, the 7th. So this is Elisa's, right?
Yep. Hi, Professor
Yay,
Wong.
hi. So let me quickly read through your questions here. Check your FFEs. Swell center line is very long. I can't, oh, okay. Your swell is there and there. Okay. Yeah, your left side, you don't probably not necessarily do this that spot. Okay, not yet. Past the ADA. Go over what this is again. Where's the number 4? I don't see a number 4 here.
Oh, I didn't do. That's just a
Okay.
general question about the requirements.
Oh, okay. Yeah, slope of the parking lot area must not exceed 5. Slope of the parking lot access drive. Okay. The entry drive of the park. Okay. Design with a 3-inch crown. So if you have designed this slope as a 2%, you don't need to worry about the crown. No. If you, this is the kind of the same question as Devin's. If you have this as 2%, then the 3-inch crown requirement has been fulfilled. Okay. And
okay.
the 5% slope, meaning this area, basically this area needs to be lower than 5. And that can be up to 8. That's the entry drive.
Oh,
Okay.
that makes
Yeah.
sense. Yeah, thank
Yeah,
you.
that's the entry drive. That's 8%. Yeah, I think our next key thing is to check the FFE. Okay, so 72. It feels like you definitely need steps here. Yeah, I'm always checking this one first because that's the most challenging, because you have to maintain a high FFE, bottom FFE because of the back. So you have a 62, 65.42. You don't need to maintain that 0.5 difference anymore. Okay.
Wait, just for that area or for the whole?
For
all
the
of my
whole
buildings?
for the whole project, the corner do not need to be lower than the FFEs anymore because the buildings are retaining walls. Or can retain soil. Yeah. So all the corners, no, they would actually be determined by your BFFE or the contours around the corner. Okay.
Then what's in the they mentioned something on our thing that we're supposed to have like a 0.5 something. What are you guys referring to then?
5 something.
I'm looking at the.
Yeah, I'm not exactly sure.
Oh yeah, the finished exterior grade is to be minimum 0.5 feet below the top FFE.
Oh, that is to ensure that you have positive drainage out of your front door. That is those need to be lower than the top FFE so that water does not get into your building.
So that's right there, but the bottom one doesn't. I don't do that.
Yeah.
Okay.
Yeah. So I'm trying to look for this, what are these elevations? So I know this one is 71.52. So you have the 2%. That doesn't seem to me ADA accessible because you have steps. Is that right? You seem to
How
have
would I
steps.
know
No,
what that's?
I think if I zoom in, I kind of see, come on. Oh, weird. Here. If I zoom in, you can kind of see that it's very different from, that is very different from this one. They should not. I think you meant 71 or 72. If there's a slope in the front porch, it could be only 2%. There's very small difference between that and that. Does that make
Okay.
sense? So basically, this needs to be guided. Okay. In order, no, in order for this to be ADA accessible, you should use the whole backwards, the whole distance here at a maximum 5% slope, calculating the BC and TC here. So if the TC is 71.5 something, and if this is 25 foot, for instance, 2%, 1 foot, this is 72.5 at most. So there's no steps. There should not be any steps here. There, it seems these spots were not calculated correctly. You don't have any steps here, which is good, right? But that is not, that seems to be too high.
Hold on.
Yeah.
How do I figure out? Should I just guess for my FFE, or should I work here first?
You work
Start
from
here.
Yes, you work from this point. You work from this point, and you basically do a 2%, all the 5%, all the way. Actually, backwards. 5% here maximum, and then 2% here for the porch. So that's how you can get an accurate calculation for top FFE. That's the highest that you can get, which should be 72 point something.
Okay.
Yeah. And then you have your ADA fulfilled. Okay.
Alrighty.
Yeah.
Is this right then? Because I kind of based this from my top curb.
This looks like it's correct.
Okay.
Yeah, because now your BC is 71.03 there. Yeah, this is definitely fine there.
Alrighty. Yeah, I can change
Okay.
that.
And you do the same for everything, for every other set, right? So you pick a middle elevation somewhere here, and knowing what that is exactly, and
Okay.
you use a 5%, and then
Maximum of 5%, right?
yes, you use a
Okay.
5% to calculate this one. And this one, you would need steps to get to your 65.42. 65.42 is a good one. Yes. Yeah. Yeah, correct. So that's the basic process of checking for every one of them. I will quickly look through the other two and see if they are close to what we desire.
Wait, you mentioned that 65.42 is a good one, but when I tried to do my swales, it dragged way down.
Yeah, because you're not using walls. You need to use walls. Okay, so the contour here. So if you have 65.224, basically your 65, no, it depends on what you design for this area as well. The 65 needs to be dragged up. So meaning that your 65, this needs to be about 20 feet to make sure that this is 65. And then the other side, you could drag it up. Yeah, this is kind of, the 66 definitely would need to be dragged up like this, forming a swell. 67 forming that swell. There's a closed one here, and then another 68 needs to be coming from the parking lot, forming like this. So the other 65 needs to come up like that, and your 64 can stay where it is.
Okay.
Yeah. So, okay. I want to try to look at your swell before we run out of time, because you have tried to develop the other. Okay, so this area. So what I see missing is actually the contour pattern in front of the buildings, which is quite critical. Okay, they help you decide. They help you determine what's the first contour that needs to turn. What I meant by that is, so 72 is very close here. 70, this is 71.
Yeah.
Yeah, so if this is 71, I don't know the angle, but we'll just assume that those are the correct angles. And so this is 2, 1, 0. 71 here is going sort of that direction. So that would need to be the first one that attached to the other side of the wall is the 70. And then you look at 69 would be somewhere here. So your original contour of 69 is like there. So can you see how you start trying to attach the original contours back here? You don't need to
Yeah,
swell.
I think so.
Yeah. So then depending on what this is, you will need to attach more until you get back to 63.
Okay.
Okay.
Last one.
Yeah.
Is my contours above? Well, it's not really contour, but my spot elevation's wrong, because you kind of like added them and it didn't match where I marked mine. Because I had 72 here. Well, this is right. I got 71, 70, and then 69's right here.
No, I was estimating.
Oh, okay.
I was estimating. Yeah.
All right. Sorry about that.
Oh, no worries. Yeah, I think for now, try not to calculate TC and BCs because you will need to recalculate. Okay?
Yeah.
Yeah. Wait until the draft, a draft like this, it's correct, or at least you think that's finished.
Okay.
Okay. No, working on these will actually be sort of a very not cost effective in terms of because likely you'll need to recalculate them later.
Yeah.
Yeah. Is there anything else that I did not touch on? Looks kind of key questions. I know you.
I think that's
asked
pretty
about.
much it.
Okay.
Because this is my main problem, and you helped me in
Yeah.
that one.
Yeah.
All right. Yeah.
So even if you
problem.
haven't decided how many steps, definitely put steps there. So to remind you that the which ones are ADA, which ones are not. Okay.
Yeah. Could I still email you because your office hours is full, but if I have questions, could I still email?
Yeah. Try to email me before the end of the business day.
Okay. Yeah.
Yeah. I'll more likely respond before the night.
Gotcha.
Okay.
Thank you.
Oh, no worries. Glad to help. I have next student. Here is Max. Are you here?
Yeah, I'm here.
All right. Would you rather wait until the end?
Yeah, I can wait until the end.
Okay. So, well, I'll talk to Seth first.
Morning.
Morning. Okay. Let's see. The questions are, should these spots elevations be the same? Not really. They would not be the same, and they will be calculated later on based on your contour locations. Okay, if you remember, well, of course, you can modify the contour to make them the same. But, no, for instance, I'll give you an example. If your contour pattern, make it bigger, the contour pattern like that, no, that would be higher than that one, right? But if you are designing, for instance, now if you are designing the contours for it to be like this, then they're the same,
Okay.
right? So you should work on the draft the contours first and then tweak them if you would like to achieve a certain goal. If you think I want to make them the same because I think aesthetically that's a better design, you can achieve that by tweaking the contour directions. But it
Okay.
will wait until you modified or semi-finalized your contours and then you calculate them. Okay. FFEs, they could be the same. I would say they would not because of that's higher, lower. So this is higher and that's lower. And so this would be overall that set, those pair would be higher than the one on the left. So the goal is to keep the two adjacent units the same, but the pairs can be different. And they would be different.
Okay, that makes sense.
Okay. Yeah.
I have had trouble finding the FFEs because I had been going down 2% from the parking lot. Like I had reversed it by accident. So then I realized that we're going like up 2 to 5% to the building. So that
Right.
changes everything.
Right. Yes. Yeah. Yeah. It's the project required that we design a crown for this parking lot, right? So yes, we're going down. No, sorry, going down that way, and then from the house to the parking lot, we're going down as well. So your original 5% slope there was not correct, and it should be 2% for that direction. But we went through quite a bit how to verify, how to draft the FFEs and to verify that they will work. So
Yeah.
And also just a reminder, you don't need to work on the HPS yet. And still work on the draft of the
I realized.
contours and then see where the HPS fall between, which two contours the HPS fall between. And then that's how its elevation is identified.
Okay, yeah, that makes a lot more sense now.
Yeah. So a typical contour pattern on the side would be like this, right?
Okay.
And then that's where your HPS would fall.
For the retaining wall over on that side, is there like a limit on how long it should be?
No, there's no limit. But on this side, I agree. It would be quite long. So right now you have a 64.87 there. So your first contour that's returning to close to original contour would be 64, right? That's 5, that's 6, that's 4. Your 68.4, so it feels like 64 needs to be somewhere there to stay about 40 feet away, right? Actually 44 feet away. It's too thick. 44 feet away, 2%. And that's your 64 contour. Does that make sense?
Yeah.
Yeah. So then your contour needs to be at least through 64. Yes, through 64 there. So that I can attach 65 here. Bad, the wrong one. 65 here, 66 there, and 67 there. Well, I take it back. It should be between cutoff there. I draw a little too long. So that needs to be end between the 5 and 4. So the 4 is the last one that can be continuous. Does that make sense?
Okay. So
Yeah.
I would want to try to move it to 65 instead, or
Yes. Yeah.
Okay.
That's right.
Okay. That makes sense.
Alrighty. Anything else that's no
I think most of
major
the
that we
troubles
haven't
I
gone
had-
through?
Yeah, the only troubles I was really having was trying to get like the FFE high enough. But now that makes a lot more sense now.
Okay.
Um,
Sound good.
One question though,
Sorry. Yeah.
the spot elevations in the parking lot, you basically just follow the center line, and find the elevation where it meets where you're gonna take the spot elevation.
Oh, sorry. Can you repeat that one?
Like if I'm trying to find a spot elevation in the parking lot, would you follow like the center line and then find the elevation where
So if
it would
you are
line
trying
up?
to calculate the spots, no, you will start with the contours of the parking lot, right? So you will start with that and that, right? And no, basically you're trying to interpolate. No, for instance, if I am to find where this is, I make a parallel line to the contour to there, and I use the slope of the center line to calculate what this spot is. But then I know what that is. I transfer all these elevations to the center line, then I know what that is.
Okay.
Okay, so the same thing here with that and that. I do that to figure out all those spots.
So you wouldn't go perpendicular.
I wouldn't go perpendicular. Well, if
Okay.
it's a constant 2% slope, you can go perpendicular as well. So there's not a single way of doing things. Yeah, if you wanted to find out this, just remember all the way through is 2% slope. But
Yeah,
I
okay.
suspect that actually creates more calculations than less.
Okay.
Because you have to find out this one and then measure this and that. So it's one extra step, I believe.
Gotcha.
Yeah, but whichever you prefer.
Okay, thank you.
Sounds good. Next one we have N. Hi, N.
Hi.
Okay, let me quickly get to your drawing here. So what would be the difference between having a swell versus just an angle of the contours? Yeah, I think we went through that. This side, you're likely to need a swell because of the long retaining wall that's usually necessary. And that one, you don't necessarily have to have a swell. And I'm generally struggling to visualize how the contours connect from parking lot to townhomes. Yes. So you'd have to need to try it out. So yes, you basically the direction is like this. The general direction is like this. but then you need to compare the location of the contours to the spots that you calculated based on that slope. Okay, so you have a general direction of the contours first, but then later on you will find that you may need to revise them based on the spots there. So the contours might be connected like this, for instance. The contours might be angling in a different angle. So next step, it's pretty challenging to figure out where exactly those contours go. But the basic principle is that no, you cannot have conflicting spots on either side of on the two sides of the contour. Okay, on the lower side, all the spots must be lower than the contour. So for instance, now I give you an example. I know this, once you have a draft, it's a lot easier to criticize it, to critique it. But coming up with the contour is actually more challenging. So for instance, if you have a 70.85 here, you know, oh, my 71 is likely somewhere there. And I have my 72 close here. I know my 72 is likely close to this area. This is 72. That's where 72 comes out, right? So no, your contour might go like this. And your 71 is not actually going to go through here because that's where your 71 contours comes up. So you won't have a spot that's lower. That's probably BC.
I thought the 72 would come out closer to the high point. If we're jumping up the curb, wouldn't it be like?
So these contours, if this is your 72, the 72 goes like that because the BC here is 71.5. So your TC is 72. So you had it backwards.
Oh, okay.
Yeah. So your 72 would go somewhere like this.
Okay.
Okay. And your 71 is doing that. And this one is likely an error. You probably calculated, oh, that's a ramp. You know, get it? That's a ramp, which is totally. Yeah, I wanted to talk about ramps once you get to that stage. But right now, treat everything with a curb. And then later on we open up openings for the ramp. I want you to try to get the contours correct, not to let the ramp confuse where the contours go. And then we break it out. Yeah, we break the curve and figure out where those contours go. If there's ever a contour that's actually hitting that ramp. Okay, right now treat everything as having a curve. Once you have these contours, we add ramps. So, otherwise, it's gonna be really, really confusing. You will find conflicting information.
Okay.
Okay. Yeah, this is the perfect example of that one.
So you would calculate the slopes based on the top of the curb and not the bottom?
Yes.
But I feel like since it's like a 0.5 of a foot difference, wouldn't it significantly impact the calculation?
So we offer you two types of ramps. Basically, you can, I'm going to draw on the other side of the drawing. So you can break the sidewalk here. Yeah, having only one sidewalk that leads to both units is it's unflexible, okay, inflexible. So we would want the sidewalk to be closest to the parking lot.
Okay.
So basically we would want your sidewalk to be like this.
Okay.
Okay. So then that area, this sidewalk area would definitely allow a ramp to go over that 0.5 foot difference. So what you do is, no, we gave you two type of ramps. The one that it's saving space is that I go up from here. That I'm not breaking any. So I go. So this is going. This is flat. Okay, that's flat. I actually have an example right here. Let me just flip to that. Did I? Oh, close it. Open recent file here. This one does not take any space, any extra space. You see this example?
Yeah.
No, moving every. So this is the central landing is flat, and then you have two small slopes, ramps that goes up to either side of the sidewalk. Doesn't take up any extra space. So that's how you get over that 0.5 foot difference without actually needing to lower your FFE.
Okay, that makes sense. Does
Okay.
that mean that the I don't know what to call it, but the parking it's not really a parking spot, but the things with the hatching in it,
Yeah.
that
Yeah.
like a break in the parking spot so that your access to the sidewalk from the parking lot has to be at that point?
You can move wherever that shading is. That's basically painting on the parking lot, indicating where the ADA spots are.
And it has to be beside the larger parking spot.
Oh, you meant how do you represent that?
Oh, not really. I meant hold on, I'm gonna try to see if I can annotate because
Yeah.
I actually don't know how to do that. But, do you know how I would? Oh, I found it. Okay. So like these things over here, that's where people walk from the parking lot to the sidewalk, and it has to be beside an ADA parking spot.
Yes.
Okay.
Yes. Yeah. This is the ADA parking, and that is where the ramp comes down, and that is where the ramp connects to where the wheelchair rolls down.
Okay.
Yeah.
I also had a question about the porch.
Okay.
So I was listening to other ones, and it was said that it has to be the same as the FFE.
Yeah.
And then there's also another requirement that the spot elevations around the building has to be 0.5, at least 0.5 feet below that. So I'm wondering if the building is ADA accessible.
Not necessarily. It meant the ground elevation here needs to be lower than the FFE. So the ground is not draining into your unit. So these are actually determined. For instance, that corner, if your backyard is actually this big, then that would be the same as your BFFE. So those are not restricted by the 0.5 difference. The 0.5 difference is meaning for the ground elevations here must be lower so water does not enter your building.
Oh, okay. But like
Yeah.
for like,
But the front porch will be the same as your TFFE to make it ADA accessible.
okay, and then like so I don't know if you can see the line that I just drew, but
yeah.
So that would be like one continuous ramp with no.
Yes, you could do that too. You could do that too.
Okay.
Yeah.
Okay, yeah, that makes sense. I just have to like rework all my numbers because I did my parking lot wrong, which means everything else is wrong. So
yeah. Well, I don't recommend focusing on the spots of the buildings at all at this point. I would recommend that you work on, once you revise your parking lot contour, work on the big contour pattern around your building in front of the building first. And it is okay to stop at this stage saying, oh, I know the rough direction of the contours in front of the building should look like this. And then Now, once you figure out these spots, determine where you need to turn your contours in certain locations to fit, to be, to match your spots. Okay, that needs to be higher than your contour. That needs to be lower than your contour. There's no conflicting spots with your contour. That's for later. Okay, otherwise you'll confuse yourself very fast.
Okay.
Okay.
I was very confused, but
That's the hardest part of this project.
yeah.
Cool. Alrighty. If you have more questions, feel free to reach out. Okay.
Okay, great.
Okay.
Thank you.
Yeah. And I believe last one is Ryan. Is that right? Trying to pull up my list here. Yeah, is Ryan here? Okay. Ryan is not here. All right.
If you had to critique his work, though, what would you say is something that he maybe needs to change?
Well, let's see. Because I don't have any questions written down, so it's really hard to find a starting point, and I don't have any FFEs.
Yeah, that's fair enough.
Yeah.
Yeah, I was just wondering because I'm just trying to understand from everybody's methodology what they, how they design.
Yeah. The first thing I would say, the slope arrows from of the parking lot are backwards. So although the tick points may be calculated correctly, but they are not. Yeah, these arrows are. Those are backwards. Those are backwards. Yeah, I think the development of this it's limited. I hope, no, Ryan, if later on you're watching the video, no, very similar. I think your workflow will be very similar to others. Correct your slope arrows first, and then work on the parking lot contours, working on verifying the FFEs, and then move forward with other steps. But yeah, I would say this is not enough, not enough progress. And if you're still at this stage, please work hard. Thank you. I will review Mac's drawing as the last one. So now let me quickly check with Stuart where he is in terms of his critique. Oh no, students, feel free to return to the main room. Okay. I don't think we have much new things to offer from this room. All right. Well, I thank you I thank everyone for your attention in this room. I'm going to return to the main room and check with Stuart. Max, I'll stay and give you the, just a second.